Hi guys, in this video we are going to create agents using local LLMs using Agno. Now you might have heard about Phidata. So I have created in fact some videos on Phidata. Now Phidata is now Agno for creating pure AI agents, future-proof, model agnostics. We are going to go step by step and create your own AI agents using Ollama or any local LLMs for that sake. Now, in creating your agent, we need a few things. So, to be called as an agent, we would need a few things. For example, model. This is the large language model that you're going to use. We need some memory, we need some storage, some knowledge base that is going to be stored in a vector database. We need tools, the different kinds of tools, and then we just put in the descriptions and use this agent. Now I have prepared a lot of examples for you. We are going to see those one by one, but this is what you would get finally. This interface where we have different agents here on the right. For example, I have 3 agents here. So web agent, you can ask questions. So give me some latest AI advancement news. This is going to use this model, Llama 3.18 billion. You can use this finance agent to get you the stock price of Bitcoin, for example. You can use this YouTube agent, which can fetch you the summary given the HTTP link of the YouTube video. So such kind of agents at your fingertips using Ollama. This is our target, but let's see how this is done. Now Agno, it's an amazing service. I have been using Phidata for so long, and just recently they have changed the name from Phidata to Agno. Now, in order to create any agents, we need a few things. So for example, we need different models. So these are the models that is being configured in Agno. So we have Cohere, OpenAI, AWS, Bedrock. You can take models from Anthropic, DeepSeek, Fireworks. You can take models from Azure. Now, for the knowledge base, you can have PDFs, CSVs, text, archive files, documents, URL, S3 buckets. We have Wikipedia. Then we have different embeddings that you can use. OpenAI embeddings, which are you need to put in a cost. We can use Ollama embeddings as well. We can use OpenHermes LLM in the local system to get your embeddings running. We can use embeddings from Fireworks, Quadrant, Azure, and so much more. For the storage, you can use PostgreSQL, DynamoDB. Then you have SQLite, Single Store, MongoDB. And these are the different tools. As you can see, there are tons of tools that you can use, because every new feature, every new action that you want to do, there is an associated tool. So for example, Apify is a tool, Calculator is a tool. We can have a Discord tool, Airflow, YouTube, Google. We're going to look at a few examples, but these are all the tools. Now, ultimately, what is our target is that we are going to have multi-model features. It's going to be model agnostic. You can use any models. It's going to be multi-agents, agents talking with each other, lightning fast, and memory management and knowledge stores. So let's go and get started. And of course, these are the vector DBs. You can use Pinecone, PG Vector in the local system or in the cloud, but I prefer to use in the local system. You can use ChromaDB. We're going to see a few examples here. So let's go and see a few examples. Now what I've done is I have created a long list of things that we can do. So first of all, let's start with this main one. So this is a basic agent. First of all, you need to install Agno. So we need to say pip install Agno, and this is going to install. And as a matter of fact, I have been testing this UV environment, is UV module. It's pretty amazing to create fast, lightning fast environments for you, and it installs pretty fast. So let's go and start this main one example. So UV run main1.py. So what this is going to do is you're going to take this as copy relative path, and then you're going to run this UV run and paste in the link. So what this is that from the Agno, we are from agno.agent, we're importing the agent, and we are importing the Ollama, and then we're using this model as Ollama as DeepSeek R1, and we are putting in markdown as true, and we ask it to share a 2-sentence horror story. And you can see this is using DeepSeek R1, which is installed on my local system. So let's go and see how we install this DeepSeek R1. Now, if you have been following my channel, I'm a great fan of Ollama. So you can go to ollama.com, download it for Windows, Linux, Mac OS, anything. So since I'm on my Windows, I'm going to go ahead and download this for Windows, get the installation file and download that. Once you have that, you can go to this model section, and in this model section, you can have a list of tons of different models that you can use. Now I'm going to show you how to install DeepSeek R1. So click on DeepSeek R1, and in the drop down you can see that you have all these variations. My system has an 8GB GPU, so I've decided to go ahead and install this 7 billion parameter DeepSeek R1. So I'm going to copy this and go to my CMD command prompt and paste it there. So once you paste this, this is going to pull this model if it's not available. If it's available, then it's ready for inference now. So I can just test it out. What is the capital of India? And let's see. Okay, the capital of India is New Delhi. So this is okay, and I'm going to exit this. And then I'm going to see the list of models that I have. Now, if you click, if you just type Ollama and press enter, you will see this list of available commands. And one of those commands is the list command. So what you can do is you can say Ollama list, and you can see this list of LLMs that I have. As you can see that I have so many different LLMs installed on my local system here. I have DeepSeek R1 installed here and DeepSeek R1 1.5 billion as well. And you can see that I have other models, for example, Quen, Llama 3.2 latest. I have Llama 3.1, which we are going to use in our examples. We have Quen Coder as well. That will be helpful for creating your coder agent. So all these local LLMs, it's pretty fun to create different agents because these LLMs are expert in their own different fields. So if you can select a proper LLM, it's pretty good for that specific agent that you're trying to create. Now, this is how we install the Ollama, and this is how you get the local LLMs installed on your system. Now let's get back to the code. So this is the code from Agno Agent. We import this Ollama here, and then we're going to use this Ollama using this ID DeepSeek R1, and this ID, it comes from the list of LLMs that, again, so this is the list of LLMs that we have. So this name comes from that list, DeepSeek R1. So this is the ID of the LLM here. Now markdown is true. This gives you a pretty good format here, and this is how we use the agent. So agent.print response, share a 2-sentence horror story. So this is the basic agent. I'm sure you're excited and want to see more examples. Let's go to another example. Let's go to main 2 here. Now here what I've done. Here what we have done is that we have tried to show the use of tools here. So we are putting in 2 number of tools here. So tools is DuckDuckGo here and the archive tools. So DuckDuckGo is a search tool and archive tool is a tool that fetches information from your archive papers. Now in this example, what I'm going to do is I'm going to ask it search archive for reinforcement learning. If I run this, let's see what you get. So this is main2.py, and let's see the output. So the LLM that you're going to use here is Llama 3.2 because not every LLM supports tools. Now Llama 3.2 happens to support tool, therefore you need to use a model which can support the tool. So it's thinking and it's searching the archive for reinforcement learning, and you can see that it gives me an example here, the top 10 papers from the list based on relevance, impact and popularity. Deep learning, deep reinforcement learning from conversational AI, and you can see that all these papers has been obtained from the archive tool. by the archive tool from the archive page. Okay, so another question is, let's say I can give me some DeepSeek R1's latest news, then it should use a different tool or DuckDuckGo tool, because this is, I'm asking it to give it latest news. So now if I run this, I should get some latest news about DeepSeek R1's. So you can see that this is the latest news of DeepSeek R1, the first impression. I've not sped the video up or anything like that. No editing on this part. You can see that's pretty fast reply and you can get this response. So this is how we use tools using Agno. It's so simple. Now, in this example, we have created a book recommendation system. Here, we have used this agent. Okay, so agent is, we can give a name. We are using the Exa tools. Now Exa is another web search, and this gives you a very good output which is suitable for the LLMs to process. So Exa tools is a pretty good web search, web scraping tool, you can say, which gives output which is relevant for the LLMs. Now we are using this Llama 3.2, and we are putting the description here, putting the instruction here, and then we are going to use this using this simple command, print response. I really enjoyed the secret book. Can you suggest some similar books? Now before we could use this, we need to put the Exa tools API key. But first of all, let's go and try to run and see the error that we might encounter here. Okay, so if I run this main3.py, we see that the Exa API key environment variable is not yet fed, so we need to put in the environment variable. Now one of the ways of doing and putting the environment variable is we're gonna set this Exa API key to the environment variable. So for getting the environment variable, we need to go to exa.ai, and here once you log in, you need to go to your API key section. So we go to API keys here and copy this API key. I've already created this API key and just paste it here. Once you paste this, it is ready for inference. So you can go and run UV run YouTube test main3.py. I really enjoy writing, I really enjoyed the secret book. Can you suggest some similar books? So this is running Exa with this category company, number of results is 10, query is book similar to the secret. And you can see that it gives me different recommendation of different books because I like the secret. Now this is an amazing book recommendation system. I will paste in all these codes on my GitHub profile. You can download and use it at your own leisure. Now let's go and see another example. This time let's go and see this coding example. Okay, so first, what you need to do is to install this Ollama SQL Alchemy Fast API to install these dependencies. Then you need to use this agent. The name of the agent is coding agent. You're putting in an ID. The model is Qwen 2.5 Coder 14 billion, and of course I have installed this on my local system. So Qwen 2.5 Coder 14 billion. Then we are going to use the storage as from the SQLite agent, and the database file that you're going to use is the local agent storage file, which is again a temporary storage local agents in my local system itself. So all things local. And what I'm going to do now is I'm going to serve this playground as well, which you will see in just a second. Now let me go and run this, so this will make clear. So I have this coding agent. I'm going to copy this relative path and I'm going to say UV run and paste in the path. This is going to load up the playground, and until now we have been using this in a CLI. It's good, but it's not that much attractive to use. Now since we have this playground, now you can use this on your playground. So this is a playground feature that has been developed by Agno, and you can see that on the right we have this coding agent that we have just created for this particular session, 7777 port, localhost 7777. We can see that we have this coding agent and we're using Qwen 2.5 Coder. Now using this, what I've done is I've created a Tetris game, and it was pretty much able to give me in a first instance just one spelling mistake of orange color. Now instead of waiting for the game, I'm going to run this game and you can see for yourself the output that we had obtained. I'm going to stop this, and this is the output that we have obtained. So tetris.py. I'm going to copy this and I'm going to paste this UV run, and you can see that this is the Tetris game. Now I'm going to play this for some time and show you that it works, and it's pretty much fun to play. So we can, by pushing on the up arrow, you can change the structure of the blocks, and if you press down, it's going to fall a little bit faster. And you can see that this is pretty much awesome game. It reminds me of my childhood. I'm going to play this for some time, and then we are going to go ahead with the other examples. Okay, so this box here, and you can push this here, and you can push this maybe here, you can push this maybe here. So we are going to have a line clear, and you can see this is pretty fun. So I'm going to close this, and once you are out, once you lose, this is going to close the game. So this is the Tetris game, which has been developed by Ollama 14 billion 2.5 coder. Okay, so this is an example of Tetris. I will put in all the codes. You can try for yourself, but you actually don't need the codes because you're going to create this on your own using a local system. Now let me go ahead and see this example. So Ollama agents here. So here what I'm going to do is I'm going to show you different agents interaction. So I'm going to make some space here, and you can see that here we have used different agents. So for example, the web agent here, this web agent, it uses Llama 3.18 billion. It uses the web search DuckDuckGo tools, and it uses storage as well. The finance agent, it again uses the same model, and it uses the Y finance tools. So for every model, if you want to make it a good agent, you need to put in some tools. So for the web agent, we put in the DuckDuckGo tools. For the finance agent, you put in the Y finance tools, and for the YouTube agent, you're gonna put the YouTube tools. Okay, so once you have these three agents, you can push those agents to the playground, and you can start and serve the playground. So again, this is pretty interesting. We have three models, so you can copy this, copy relative path, and you can go ahead and UV run and paste, and this will open up the playground. So you can go to localhost 7777. I'm going to go ahead to the playground here, click on open. This will open the playground, and you can see that we have three agents here. So at the start of the video, I've shown you this feature. You can see that web agent, so you can ask what are the latest advancement of AI. You can go to this finance agent, you can ask the price of Bitcoin. You can go to this YouTube agent and ask, and just put in the HTTP link of your YouTube video, and it will give you a summarized description of the YouTube. Now there are a host of different agents. If you go to their page, you can see that if you go to the documentation, you can see a host of different agents that you can use, different tools that you can use, that you can try and use it. Next, let's go to this study partner. So this is another simple example. Here we have used the Exa tools and YouTube tools, and then you put in some description, you put some instructions. So imagination is the limit now, because we have access to so many different and easy way to create agents that you cannot go wrong. So if you find yourself stuck, there are guides on the doc section of Agno, and you can use that to resolve your queries. Now this RAG system you can use, but you can probably use the Ollama embeddings using OpenHarmos. Okay, so we have this example. You can see that we have used the embedder as Ollama embedder here, and we have created a knowledge base. Using that knowledge base, we use that knowledge base and put it in the agent itself. Now the agent is going to use that knowledge base and come up with answers. Now, this is the first video in the series. I have so many different examples and so many things to say about Agno, but please subscribe to this channel and watch out for the next video, because this is the revolution and it's amazing to be able to create agents like this. Now in the next video, maybe I will create a list of 20 agents talking to each other, thinking what's best to do for your question, for your prompt, and coming up with the best solution. Until then, please subscribe and I will see you next time.